Here in Northern California, on the western slope of the Sierra Nevada, flow the clear, sparkling waters of the Feather River. A river once prized for its gold. A river once feared for its floods. Today, the floodwaters of the Feather River have been tamed and stored here in the foothills as the primary water storage facility for the California State Water Project. This has been made possible by an outstanding engineering achievement, Oroville Dam. At the dam site, work began on the first of two tunnels, which would divert the river during dam construction. Part of the river channel was closed off. This allowed crews to expose the bedrock on which the dam's concrete core block would be built. In 1963, the placing of earthfill material began. The contractor, Oroville Dam Constructors, modified an abandoned railroad to move the earthfill material 12 miles from a gold dredge tailing area to the dam site. A huge bucket wheel excavator scooped up rock and gravel at the rate of more than 3,500 cubic yards per hour. The material was sent on conveyor belts to the train loading area. After it was screened, the material was sent by conveyor belt to train loading hoppers. By filling 10 cars at one time, an entire 40-car train was loaded in less than 15 minutes. 3 sets of locomotives continually shuttled the cars between the dam and the Boro site. At the unloading area, the cars were dumped automatically without needing to be uncoupled. The material again rode the conveyors. The impervious clay going right to the dam, and the coarser material going to a mixing and temporary stockpiling area. Each type of material went to its own specific part of the dam, where it was dumped, spread, and packed down. Inspectors monitored the operation constantly to maintain quality control. In 1964, the second diversion tunnel was completed. By the end of the year, the construction of the upstream portion of the dam rose to 425 feet. In December of 1964, a record flood roared down the forks of the Feather River. But Oroville Dam was ready. And although only partially finished, it controlled the flood, saving downstream farms and cities millions of dollars in damage and possible loss of life. Meanwhile, deep within the left abutment of the dam, the powerhouse was being carved out of solid rock. Up top, construction continued around the clock to build Oroville Dam. Day by day, week by week, the dam grew. When completed, it would stand 770 feet high. It would be 6,900 feet long, 3,500 feet thick at the base, and contain 80 million cubic yards of earth material. In 1967, the final load of earth was put in place. The last diversion tunnel was closed, and Lake Oroville began to fill with water, 1 year ahead of schedule. Oroville Dam's powerhouse, later to become the Edward Hyatt Power Plant, was also nearing completion. It had been almost 7 years since ground was broken to begin construction, and it was time to celebrate again. On May 4th, 1968, Oroville Dam was formally dedicated by Governor Ronald Reagan.
Here before you is Lake Oroville, filling to its destiny for the use of flood control, hydroelectric power, irrigation, municipal and domestic purposes, and as one of the greatest recreational and fishery lakes in California. And off there, is the highest dam in the United States. This is a major achievement of our time, and it's with great pride, therefore, that I simply dedicate Oroville Dam and Lake Oroville to the people of California's future, who will benefit from this giant structure and the water that it impounds. Thank you very much.